Hi, this is Manjeet here, and in today's session, we are going to discuss about decrypting the SSL traffic and taking a TCP dump on the IDP server to debug a issue. So, first of all, we need to understand why do we need to debug the SSL traffic and TCP dump in NAM. So, there are certain scenarios when logs are not able to capture each and every information, and and also in some cases customer are not ready to put the debug logging on their system because debug logging fills the disk space very quickly. So there are some cases when you need to take a TCP dump or a Wireshark capture of either IDP system or AG system, and then you have to decrypt the packet to see the interaction between the different element like the interaction between the browser with access gateway, interaction between access gateway and the IDP, interaction between browser and IDP, interaction between identity provider and access gateway, interaction between identity provider and e-directory. So wherever the traffic is SSL related traffic, and we don't have enough information with respect to logs, then we need to take a TCP dump or a Wireshark traffic, and we need to decrypt that. There is one more case where when AG is communicating with the ESP for policy evolution, we need to see that traffic also. So in that case, we need to take the TCP dump and see the packets. Uh, another case is when AG is communicating with the web server, and that communication is also SSL. So wherever the SSL communication is there and we don't have enough information with respect to log, then we need to probably go for the decrypting the SSL traffic. Before decrypting the SSL, before going forward, I just want to talk about very basic about the encryption here. The the basic use of using the SSL between a client and a server is to encrypt the data. So when a client sends a data to the server, it should be in encrypted format, and when the server sends a data to the client, it should be also in the encrypted format so that no attacker will come in between and see these messages. So to understand about this encryption, we need to understand about little bit about the cryptography. So cryptography is basically the field where this encryption comes in picture. It is divided into two categories. One is the symmetric key cryptography, and another is the asymmetric key cryptography. These two fields are actually used to uh, are the field where we discuss or study about the encryption. First, take the example of the symmetric key. Symmetric key is basically is an encryption method, you can say, where it uses some algorithm to encrypt the messages, and that algorithm uses a key. Uh, in this kind of cryptography, there is only a single key which is shared between a sender and a receiver. So whenever a sender wants to send some message to the receiver, it uses that key or uses this symmetric key to encrypt the message, and when that message arrives at the receiver uses the same key to decrypt the message. So there is only a single key which is shared between both the sender and receiver. This cryptography method has uh, has lot of pros and cons, but we will discuss which is actually uh, which we actually going to look in our TCP dump and the further analysis. So the main important pros with this is it is very fast in nature. Computation is very fast, but the disadvantage is the key exchange issue. Key exchange issue is in the sense as it is using a single key for the encryption and decryption both, this single key should not be shared with any other third person other than sender and receiver. So if A is sending a message to B, it's the shared key should be only known to either A, to both A and B, not a third person C. So this key exchange is actually a issue in symmetric key cryptography, that how they are going to exchange this secret key between themselves. There is another the solution of this cryptography method is asymmetric key cryptography. Asymmetric key cryptography, in place of symmetric key cryptography, it uses two keys, and you can say it's a public key and a private key. So every element who wants to talk with the other element in encrypted, who wants to send an encrypted message to the another, will they will have a private key and a public key. So for example, if A wants to send a message, an encrypted message to B, what A has to do, A has to use the public key of B to encrypt the message, and B has to use the private key of B to decrypt the message. Similarly, if B wants to send a message to A, B will use the public key of A to encrypt the message, and A will use its own private key to decrypt the message. Okay, so it also has a pros and cons. What's the process? There is no key exchange issue, because the private key, which is actually responsible for decrypting the message, is never shared with any other element. It is always private to the entity. The only key which is exchanged is the public key. So even this public key is taken by any other third party, there is no problem in this case. The cons in this is actually computationally very slow. So in when we do a SSL communication, when a client does a SSL communication, it uses either symmetric key or asymmetric key cryptography. Now, symmetric key cryptography, as I said, it is fast, but it has a key exchange issue. At the same time, asymmetric key cryptography is actually, there is no key exchange issue, but it is very slow. So because of this, both the method has advantage and disadvantage. To overcome from this situation, the SSL uses a mixture of both symmetric key and the asymmetric key cryptography. How it is used, that we can see later. Okay, I can show you. This is a call flow diagram. This is very basic call flow diagram. Uh, let's talk about this, and then later we can relate it with the TCP num captured on one of the um, NAM boxes, IDP server or access gateway. So so you can see here, for every SSL communication there should be a client and there should be a server. So this server will be either IDP server or access gateway server. This client this client can be a browser, uh, it can be a browser, an application, or if there is a if suppose there is a request sent by access gateway to the IDP server, the client will be access gateway. So client is basically one who is starting the communication, and the server who is responding for the communication. So if you see, this is the SSL handshake which happens between the client and server communication. So again, I'm not going into very much details here. We'll just go through the basics of how this SSL communication happens. So the first thing what client does, client sends a packet called client hello packet to the server. Client hello packet basically contains a random string which is generated by the client and a cipher list. Cipher list basically contains the list of cipher. Cipher is something which tells that what kind of algorithm is used, should be used for the encryption. Okay. So client sends a random string and a cipher list to the server. What server does? Server receive it and server sends another message which is called the server hello. Server hello contains one random string which is generated by the server and it sends a selected cipher from the list of cipher given by the client, and also the server sends its certificate. Now as we discussed before that when a party want to send encrypted message to the another party, it encrypts it using the public key. So the server has to send its public key so that when the client will send any encrypted message, it will use this public key to encrypt the message. Okay. So after that, what client does, client creates a pre-master secret key. This pre-master secret key is basically used with the random string which client has generated and the random string which server has generated to create a master secret key. Okay, and then after creating the master secret key, client sends a message called client key exchange where it sends the pre-mastered shared secret to the server. And once this pre-master secret key received by the server, server also creates a master secret key here using the pre-master secret key and the random string from the client and random string from the server. Okay, but here you can see this pre-master secret key created by the client is actually encrypted using the public key of the server and sent to the server. Now, as this pre-master secret key is encrypted using public key of the server, it can be decrypted only using the private key of the server. So after the exchange of the client key exchange message, the server will receive the pre-master secret key in an encrypted form, and as it is using the public key and the private key concept, this key will be only available between the client and server. No other third party will have the pre-master secret key. Once server gets the pre-master secret key, it uses again the same method to create the master secret key. The master secret key is created using the pre-master key and the random string from the client and random string from the server. Once this operation is done, all the traffic between the client and server will be encrypted using this master secret key. So you can see here the public key cryptography or asymmetric key cryptography is only used to encrypt the pre-master secret key. But the rest of the traffic is encrypted using the master secret key, which is using the symmetric key cryptography. So this actually using a mixture of public key asymmetric cryptography as well as symmetric key cryptography. So as we discussed before, the asymmetric key cryptography is very slow in nature. So if you encrypt all the messages between client and server using the asymmetric key cryptography, the communication will be very slow and it will consume a lot of resources. So for that, only the uh, it it uh, it encrypts only a secret key between the client and server using the public key cryptography, and once this is received, that key is received by the server, the all the traffic is encrypted using the master secret key. Okay,